Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to solve the questions, organic chemistry question that were asked in IIT JAM 2025 chemistry paper. So in this video, we'll solve the organic chemistry based question that were asked. So this was a question that was asked based on baeyer-vileger oxidation followed by reduction. Then this was the question that was asked based on E2 elimination reaction. Then this was again based on a name reaction, that is benzil-benzilic acid rearrangement and benzoin condensation. Okay, so coming on to this question, we have to find out the product of the reaction. So in Baeyer-Vileger oxidation, what happens? Basically a ketone, okay, it gets oxidized to an ester. Okay, so the question is, suppose there are two R groups, R here and R dash here. So the question is, this oxygen will be inserted at which position, this one or this one? That is the question. So it gets inserted at the electron rich site. Okay, the group that is electron rich, their oxygen will be inserted. Now here this is the carbonyl. So there are two positions here. Here you can see there are two hydrogens and one carbon. So this is, and there is another one, this carbon. Here you can see there are two carbons and one hydrogen. Okay, so where it will be inserted? At this side, because here two carbons are there, that will be donating via plus a inductive effect. Okay, so what will be the product of Baeyer-Vileger oxidation? Okay, this bridge will remain same, OCH2 pH, and here the oxygen will be inserted, C double bond O CH2, like this. Okay, this is the first one. Now coming on to the stereochemistry. Okay, now the second one is LH reduction, lithium aluminum hydride. We know it donates H minus, donate via reduces via hydride ion donation. So now here if you see, this hydrogen is below, and here also if you see from the top, okay, from the top if you see, both the hydrogens are below the plane. Okay, and this bridge is present at the top. So this hydride ion will attack from which side? The top face is blocked, so the hydride ion will attack from the bottom, face. Okay, that is dash bond, and then this will be open up. Okay, you will get an aldehyde. Okay, OCH2 pH. Now here this is below the plane, so you will get this group above the plane, CH2 C double bond OH. Then here H is below the plane, so OH will be above the plane, like this. Okay, and then we know LH, this further reduces this to primary alcohol. So what will be the product? The product will be CH2OH. Now if I want to write down in the normal wedge dash configuration, so here you can see there's 1, 2, 3, 4 and 5. Okay, so there will be a 5-membered ring. Okay, OH is what? OH is above the plane. Then with respect to this OH, the bridge will be what? Bridge will be below the plane, okay, on the opposite side. So this will be below the plane. Okay, this group, entire group will be below the plane. Okay, CH2O, CH2PH. And then here again, this entire group CH2, CH2OH. Okay, this is above the plane. So this is going to be the final answer. Okay, so OH and CH2, CH2OH both are above the plane. So that is only option D is the correct answer, and this entire thing is below the plane. So the correct answer for this question is what? Answer is option D. Okay, moving on to the next question. So here what you have to do is, base is given, we have to do an E2 elimination reaction. And what is the E2 elimination reaction? Stereochemistry condition, the hydrogen, okay, next to the leaving group. Okay, or you can say alpha to the leaving group should be, it's an important condition that we know, it should be anti-periplanar. Hydrogen and what should be anti-periplanar? Leaving group. Okay, so what we have to do is we have to draw the chair conformation for this one, both the structures. So here above the plane there is tertiary butyl group, then here Br is above the plane, and CO2H here it is above the plane like this. Now when you add the base, okay, alpha to this, which two carbons are there? This one and this one. So there are two possibilities. One is this proton, orange one, and another one is this green one. So which one will be abstracted? The one which will give you the stable product, that is more substituted alkene. So base, it will abstract this proton and we will get a more substituted alkene. Okay, why more substituted alkene is stable? Because of the hyperconjugation. Okay, so you get double bond, and here there is CO2H, and above the plane there is this tertiary butyl group. Okay, and similarly we have to draw for the other one. Now second one, if you see, okay, Br and tertiary butyl group position is same. Here CO2 is what? CO2H is below the plane. Okay, so now the only position left is this one. Okay, this proton will be abstracted. Base, okay, it will abstract this proton, and what we will get? Double bond C CO2H, and here tertiary butyl group is above the plane. Now here, sorry, the double bond position will be here. Okay, now here if you see, what will happen is there is a possibility of a decarboxylation. Decarboxylation means loss of CO2. Okay, this will abstract this proton and CO2 will be lost. This minus will pick up this proton and it will become alkane. So what will be the final product here? Okay, this is going to be the final product. Now the question is, why in the second case decarboxylation took place, but in first case it did not take place, right? So in the first case, if you see, if you do the decarboxylation, you will get a negative charge on a sp2 hybridized carbon. Okay, that is going to be less stable, whereas here if you get the negative charge, here if you got the negative charge, it is stabilized by resonance. And always remember, loss of CO2 takes place only when the carbanion generated is what? Is it stable? Okay, when the carbanion is stable, then only decarboxylation will take place, or else it will not take place. Okay, so what are the correct answers? Correct answer will be what? Option D. Okay, this one, and then loss of CO2. First one CO2 is given, here also CO2H is given. Okay, and this one is incorrect. This is the only correct answer. Okay, coming on to the next question. The correct order for the rate of mononitration. So here we are talking about what? Rate of electrophilic aromatic substitution. What is the electrophile? Nitronium ion. Okay, in case of nitration, what is the electrophile? Nitronium ion. And what is the electrophile? Electrophile is going to be the benzene ring. So greater the electron density on the benzene ring, okay, more will be the rate of the electrophilic aromatic substitution. Okay, so which one is going to be most electron rich? OMe, right? OMe, it is what? It is an electron donating group and ring activating group. Okay, now if you see the halogens, they are what? Halogens, fluorine and bromine, they are what? They are electron withdrawing, okay, or you can say deactivating groups. Okay, that means because of the inductive effect they will withdraw electron density, but they are orthopara directing as well. Okay, they are deactivating and orthopara directing, and methoxy is what? Activating and electron donating groups. Okay, so the halogens will be lowest. Okay, benzene will come in the middle. Okay, so only A and B, the anisole is more reacting, and then benzene will come. Okay, and then between fluoro and bromine, which one will be more reactive? Now the size of fluorine is very less, so there will be repulsion between these lone pairs. Okay, because of the very high electron density, this will be willing to donate more. Okay, although the fluorine electronegativity is higher, still fluorobenzene is more reacting towards electrophilic aromatic substitution because of the repulsion between the lone pairs. Okay, and then last will be Br. So what will be the correct answer? Correct answer will be option B. Okay, this question, a pericyclic reaction involved in vitamin D2 from ergosterol. So this is getting converted to this. So do not get scared by this big structure. You can see that this part is same. Okay, and then this remaining entire part is going to be the same, right? So what is changing is only this 6-membered ring. So we'll draw that and we'll do the reaction on that. Okay, so here there is some groups. Okay, and then there is this 6-membered ring, and here there is this methyl group. Okay, like this. So now we have to convert this into what? This into this one, right? So first thing that you can notice is what? Is that there is a ring opening, right? So what we will do? We will do a ring opening reaction. So that will be which reaction? 6 electrons are involved. So 6 pi electrocyclic ring opening reaction. Okay, so what you will get? Double bond. Okay, so here there is this methyl group, double bond, double. Here there is a double bond, then here there is this group, right? So this is going to be the, and this is the structure that we got, right? And here there is this entire ring. Okay, so is this the final product? The answer is no. What is the final product here? The final product is you want a double bond here. Okay, means at this position you want a double bond. Okay, this is a part of the other ring. Okay, it is, that is not methyl. Okay, so here you want, instead of methyl you want a double bond. So what you will do? Here there is CH2H. So you number hydrogen as 1. This one will be 1, 2, 3, 4, 5, 6 and 7. Okay, so 7. So what you do? 1, 7 sigmatropic shift. So how it will take place? This double bond will move here, this will move here, and this will move here. Okay, and then here this position hydride will come. Okay, and then you will get this desired structure, double bond between 3 and 4. Okay, so 1, 2, 3, 4, 5, 6. Okay, so 1 and 2 became double bond, 2 and 3 became single bond, 3 and 4 it was single, it became double, and 5 and 6 will also become double bond. Okay, so you can see now we got this desired structure. So the correct answer will be option A, 6 pi electrocyclic ring opening followed by 1, 7 sigmatropic shift. Correct answer will be what? Option A. Okay, now this question, Okay, dialdehyde is there. So always remember when this type of there and CN is there, which condensation takes place, the name reaction called as benzoin condensation. Okay, and how does it take place? We'll see the mechanism. C double bond OH. Okay, and here also C double bond OH. Now you are adding what? Cyanide ion. So it will add to any one of the carbon atoms. Okay, this will open up. C O minus KH and Cn. Okay, and here there is C double bond OH. Now what will happen? Now this will shift here. Okay, or there is one thing that this hydride will migrate here and this will open up. Okay, so what you will get? Okay, this O minus will pick up proton from the ethanol and it will become OH. Okay, this attacked this carbon. So how many membered ring is forming here? 1, 2, 3, 4, 5 and 6 membered ring. Okay, so H and O minus. Okay, so now what will happen? Here it was O minus, right? So O minus will come here. Okay, and Cn will be lost. So what we will get is, okay, a 6 membered ring. So you will get a C double bond O and here O minus will pick up H plus ion. It will become this. So what is this? This is beta. Okay. Okay, alpha hydroxy ketone. That is the product. But is this the final product that we are going to get? The answer is no. Now the second one that they have given is dilute HNO3. Okay, so what it will do? Dilute HNO3, it will oxidize the secondary alcohol to ketone. Okay, now this is called as benzil. Okay, so this will undergo another name reaction that is called as benzilic acid rearrangement. Okay, so that we'll see now. We'll erase this. Okay, so this is a product that we got, diketone. Now OH minus is added, so that OH minus will add here at any one of the carbonyl groups. O minus OH. Okay, so now what will happen is this will come here and then this entire bond will migrate here. Okay, at this carbonyl group and then this will open up. So how many membered ring you will get? 1, 2, 3, 4 and 5. Okay, so what you will get? This is the benzene ring. Okay, this bond got broken, right? Okay, so you will get a 5 membered ring. Okay, and here you have O minus, that will become OH, and then here you have C double bond O, OH, right? This was the bond that got broken, okay, and we got a 5-membered ring. So 5-membered ring with OH and C double bond OH. So it was a very good question. Okay, the correct answer will be what? Option A. Okay, it is a combination of two name reactions. Okay, very good question. Then benzoin condensation, then benzil-benzilic acid rearrangement. Now, an organic compound produces a meso compound on treatment with this OSO4 NMO. So what is this? This does a reaction called as syn dihydroxylation. Okay, syn dihydroxylation. So whenever there is a question of this, syn means attack from the same side. What is attacking? Di means 2. 2 hydroxide will be attached to the alkene from the same side, and we want a meso compound. Meso compound means alkene, and then what? The R groups must be same. Okay, then only when you draw a plane of symmetry, okay, this part and this part both will be same. So in which case, first we have to see meso compound is possible. Octene 1, 2, 3, 4, 5, 6, 7, 8. Okay, and 3 octene and 4 octene. Let us see 3 octene. Now here there is a ethyl group, and here there is this propyl group. So this cannot form a meso compound. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Fourth position double bond. Here there is a propyl group. Here also there is a propyl group. Right? So this can form. So either the correct answer can be A or B. C and D are incorrect. Now between A and B, how you identify? So there is one mnemonic that you can remember. CAR TAM. Okay, A stands for anti-addition. Then C and T, this stands for cis and trans. R is racemic and M is meso. Okay, so cis alkene, it gives racemic product, and trans alkene will give what? Meso. But this is in case of what? This is in case of a anti-addition, and in case of syn addition, here we want syn addition, so it will be opposite. Cis alkene will give meso compound, and trans will give what? Trans will give a racemic mixture. Okay, so cis will give a meso compound. In this way you can directly mark the answer as B. And how does this exactly take place? So here cis alkene, both the OH will add from the same side. You can see these groups are same, right? Here it is CF3. In our case it is a propyl group, right? 3 carbons, 3 carbon on both the side. So you will get meso, and trans you will get a racemic mixture. Okay, next question. So in this one, what was the answer? Option B. Now here the correct order of dipole moment. Okay, so dipole moment basically depends on two things: charge separation and the bond length. So what you are expected to do in this question is you draw all the 4 molecules: chloromethane, methanol, chloromethane, and diethyl ether. Now on the first glance, if you see, you might think that fluorine is more electronegative, and that should be having a greater dipole moment, right? And if you mark any of the option A or B, that would be incorrect. Why? The answer is dipole moment. The electronegativity is the charge part, okay, the charge separation. But the major factor here you have to consider is the bond length. Okay, you have to see the bond length as well. Okay, now if you compare fluoro and chloromethane, okay, dipole moment directions, if you see the methyl part, it is going to be the same in both the case, right? Only difference is the CF bond, and here it is a CCl bond, right? Both the directions are towards the halogen. But fluorine chlorine bond, fluorine is smaller in size, and okay, so what, the CF bond will be shorter. and CCl bond, if you see, it is going to be longer because the size of chlorine is bigger. So CCl bond is greater, so the chloromethane will be having maximum dipole moment, then will be fluoro. And now between this and this, how you can compare? Now if you compare halogens with this OH, you can see the dipole moment direction is opposite, right? The carbon halogen, so this OH, you can see the direction is opposite, so it will have a lower dipole moment, but OH bond is more polar as compared to the carbon oxygen bond. Okay, so that is why methanol will be more polar as compared to diethyl ether. Okay, in halogen and methanol, why methanol is lower dipole moment? Because the direction is opposite. Okay, oxygen, this direction is opposite as compared to methyl, the overall vector will be like this, so it get cancelled. Okay, the dipole moment get cancelled, that is why methanol will be lower. So the correct answer will be what? Option C. Okay, the important thing that you have to consider here is that you have to see the bond length as well. Okay, not only the electronegativity or charge separation. Okay, this question. Now here LDA, lithium diisopropyl amide. Okay, this is the structure of lithium diisopropyl, 2 isopropyl group, and amide. This is a base. Okay, it is what? It is a bulky base, so it will abstract proton from the less hindered side, this one. Okay, and then this will attack and you will get what? This is going to be, if you draw the enolate, it will be like this, double bond will become like this. Okay, so this is what? This is a kinetic product. Why? Because here we are forming a less stable or less substituted and less stable alkene. Okay, whereas, okay, so this will attack from the this side. Okay, that is the less hindered side. So what will be the product? P will be, you will get CH2PH here. Okay, this is P. Now NaH, it is a smaller in size, so it will give what? It will abstract proton from this side. Okay, and you will form the enolate here. Okay, and then this will attack here and you will get the product Q. C double bond O, methyl, and you will get the product like this. This is going to be the Q. And here if you draw the enolate, it will be like this. Okay, it will be what? Tetra substituted. Okay, so this is going to be what? Thermodynamic product. Okay, because the alkene is more stable. Here it was what? It was a tri substituted alkene, 1 2 3, and here there was one hydrogen. So tri substituted alkene, this will be thermodynamic product. So what is the correct answer? P and, okay, the correct answer here, it will be what? Option D. Okay, that's it for this video. Remaining questions we will see in the coming video. Thank you.